Okay, we're going to work through the warm-up entitled 6.2 review together now. So the first problem asks us to evaluate sine of 22 degrees, 15 minutes, and 7 seconds. The easiest way to do this is to use the DMS template on our calculator. So I'm going to show you how to do that now. So we'll take a look at the TI Inspire. So to enter this function, we're going to hit the trig key, paste in sine, and then to get an angle in degrees, minutes, seconds format, use the template key. So the template key is just to the left of the book. So when I hit that, or when I push that, I get this template in the second row. The first cell is to put in an angle in degrees, minutes, seconds. So I'm going to hit enter. And now I can easily enter 22 degrees. If I hit tab, it'll go to the next entry cell, 15 minutes, tab, and 7 seconds. And then when I hit enter, I will get the sine of that angle, which is 0.379. When we're computing the sine of an angle, we don't need to worry about well, here I don't need to worry that my calculator is in degree mode as opposed to radian mode, because I can force the angle to be in degrees using this template. So even if my calculator was in radian mode right now, I can do the same calculation and I will get 0.379 because the angle is in degrees by using by virtue of using this template. So now we're going to go back to the worksheet. So I'm going to share that. Okay, so we found that the sine, oh, let me get that. Sorry, that didn't work. Here we are. The sine was 0.379 using the DMS template on the calculator. Problem 2 is one where we're going to use trig identities to evaluate trig functions without knowing the value of the actual value, which is going to be in terms of some constant that's given. So here we're told that cosine of 10 degrees is A. We don't know what A is, but using that information, we can find out other trig ratios. So the letter A asks us to find out what sine of 80 is. So you'll notice that 10 degrees and 80 degrees are complementary. When you have complementary angles, you'll want to think about the cofunction identities. So the cofunction identity here is that sine of 90 degrees minus theta is equal to cosine of theta. So if 80 is 90 degrees minus theta, so we can think of sine of 80 is sine of 90 degrees minus theta. That means that theta here is 10 degrees. So this will be sine of 90 degrees minus 10 degrees. And that's going to be equal to cosine of 10 degrees. But we were told that cosine of 10 degrees is A. So sine of 80 degrees is A because sine of 80 is the cosine of the complementary angle. Next problem says, what's the secant of 10 degrees? We're going to use the reciprocal identity here. So this will be the reciprocal identity. And that is that secant of 10 degrees is 1 over cosine of 10 degrees. So this will be 1 over cosine of 10 degrees. And we were told that cosine of 10 degrees is A. So this is 1 over A. Letter C, sine 10 degrees. How can we figure out sine 10 degrees if we know cosine 10 degrees? So here we can use the Pythagorean identity. And there are 3 of them. The one that relates sine and cosine is that sine squared theta plus cosine squared theta is always equal to 1. So we want to know sine of 10 degrees. So we would have sine squared of 10 degrees is equal to cosine squared of 10 degrees. Oh, I'm sorry, not equal to, plus cosine 10 degrees is equal to 1. Cosine of 10 degrees is A. So this becomes A squared So sine squared 10 degrees plus a squared is equal to 1. So sine squared 10 degrees is equal to 1 minus a squared, subtracting a squared from both sides of the equation. And now we can take the square root. And so sine of 10 degrees is the square root of 1 minus a squared. Technically, it's really plus or minus. There are actually two sign values that will satisfy this. But for this problem, I said just take the positive square roots. So those will be angles in the first quadrant. Okay, next, we're asked to find cosecant of 10 degrees. Once again, we can use the reciprocal identities. And the particular one we want here is that cosecant of theta is 1 over sine theta. So we just found sine of 10 degrees. So cosecant of 10 degrees is going to be 1 over sine of 10 degrees. So that's going to be 1 over the square root of 1 minus a squared. And in these problems, we typically do not rationalize the denominator. So just leave the square root of 1 minus a squared in the denominator. Next one, we're asked to find tangent of 10 degrees. We can use the quotient identity. And that's tangent is of 10 degrees is sine of 10 degrees over cosine of 10 degrees. And we've already found sine of 10 degrees and cosine of 10 degrees. So sine of 10 degrees was the square root of 1 minus a squared, and cosine of 10 degrees we were given is a. The last problem in this set is to find cotangent of 10 degrees. We can use another one of the reciprocal identities. And this one is that cotangent of theta is 1 over tangent of the theta, of that angle of theta. So cotangent theta is cotangent 10, I'm sorry, is 1 over tangent 10. And 1 over tangent 10 is the reciprocal of what we just found, right? So we just found tangent 10. So this is going to be the reciprocal of the line above. So this will be a over the square root of 1 minus a squared. So we have successfully used identities to find all these trig values. Okay, the next problem, we want to verify a trig identity. And remember, when verifying a trig identity, we're going to choose one side. We're going to work solely with that side. And then step by step, we're going to show how we can transform that one side into the other side. Typically, we start with the more complicated side. So here, that would be the left side of this equation, which is cotangent theta over cosecant theta. So one strategy that we can use is we can write all trig functions in terms of sine and cosine. So I'm going to do that and hope that this will simplify to cosine theta. So cotangent theta, I can write as cosine theta over sine theta using the quotient identity. And cosecant theta, I can write as 1 over sine theta using the reciprocal identity. The next step now is we have fractions that we're dividing. So when we're dividing fractions, you take the reciprocal of the denominator and you multiply. So the next step would be cosine theta over sine theta times sine theta over 1. And here we can cancel out the sine theta from the denominator of the first fraction with the numerator of the second fraction. And that leaves us with cosine theta, which is equal to cosine theta. So we have verified this identity. Problem 4 says, without using a calculator, find theta, so the angle, such that cosecant theta is equal to 2. So at this point, if we don't have a calculator, there's only a few trig values a few angles that we could have. And those are the ones that are coming from 30, 60, 90 right triangle or 45, 45, 90 triangle. So I am going to use the 30, 60, 90 triangle. As you do more examples, you'll recognize that when you have cosecant theta of 2, that's the triangle you need to use. But I don't really like to think in terms of cosecant theta, so I would rewrite this in terms of sine theta. So sine theta is reciprocal of cosecant theta, so sine theta is 1/2. And sine theta is the length of the opposite side over the length of the hypotenuse. So I'm going to go ahead and draw in my special right triangle. And I'm going to use the 30, 60, 90 right triangle, or in radians, this will be pi over 3, pi over 6, 90. And in this triangle, if I label the side lengths, the side opposite the 30-degree angle is the shortest side, its length is A. The side opposite the 90, the hypotenuse, has a length of 2A, and the side opposite the 60-degree angle has a length of A rad 3. And now I need to take a guess. So when sine theta is 1/2, I'm going to look, this would be the opposite over the hypotenuse. So the opposite side could either be A or A rad 3. If I want to take A or A rad 3 and divide by 2A and end up with 1/2, I'm going to pick the 30-degree angle. So let's check that. So if I choose the 30-degree or pi, oh wait, I wrote these angles wrong. Sorry, let me fix this. 30 degrees is pi over 6 and 60 degrees is pi over 3. Sorry about that. So I'm going to choose the 30-degree angle or pi over 6, and let's check what we get. So if we do sine of 30 degrees, that's the length of the opposite side, which is A, over the hypotenuse, which is 2A, which is 1/2. So this angle is 30 degrees or pi over 6.